Welcome back. So today's topic is why the moon doesn't fall onto the earth. Before beginning with it, let us discuss a few concepts of circular motion, just a revisit type. So let's start. So in circular motion, see, let's start. So this is a center, this is a circular path, an object, point particle, we can assume it, of mass m is moving. This is a line joining the center and the particle, the radius vector. Okay. Now particle's velocity is perpendicular, always perpendicular to the radius vector. Therefore, the force acting on it is towards the center is always perpendicular to the velocity of the particle. One question, is the velocity of the particle changing with time? Yes. Is the speed changing? Depends. Speed of this particle can change only if there is a tangential force, force in this direction, tangential force. If force in this direction is 0, then in that case the tangential velocity of the particle doesn't change. Tangential speed, tangential speed. The velocity of the particle will change irrespective of what happens in circular motion. The velocity of a particle will always change. Why? Because direction of velocity changes. When it is here, it is having a velocity in this direction. When it is at this point, it will having a velocity in this direction, perpendicular. So direction of velocity, let it be v2. Direction of velocity is changing every time. Therefore, some net force must be acting, and that net force is the centripetal force. Centripetal force is also changing, not the magnitude but the direction. Centripetal force, first it is acting in this direction, then in this direction. So centripetal force is also variable in direction, not in magnitude, because the magnitude of centripetal force depends on speed of particle. Since the tangential force on particle is 0, the speed of particle will remain constant, so the centripetal force will also remain constant. So what is the work of centripetal force? The work of centripetal force is to change the direction of particle. At every instant, here we see that velocity of the particle is perpendicular to the direction of centripetal force. So centripetal force is responsible for changing the direction of the particle. The value of this centripetal force is equals to mv square divided by r, where m is the mass of the particle, v is the speed of the particle, and r, magnitude of centripetal force, r is the radius of the circular path. This centripetal force is not a new kind of force. In nature, there are only certain fundamental forces are there, electromagnetic, nuclear, strong forces and weak forces are there. But this force, centripetal force, some other force is taking the shape of centripetal force. Centripetal means the direction, centri means center, centripetal means center, towards the center. Like this centripetal force can also be provided by the tension force, gravitational force. Like the planets, they are revolving around the sun. Some centripetal force must be acting. In this case, gravitational force is the centripetal force. So if we tie a stone in a string and then whirl it like this, some centripetal force must be acting. And who provides the centripetal force? The centripetal acceleration, the tension force. The tension force is taking the form of the centripetal force. So these were the major concepts of circular motion to understand this. So let us proceed. So what was today's topic? Why the moon doesn't fall onto the earth. There are many wrong explanations regarding this topic. So let us first discuss those wrong explanations. It will help us to remove our misconceptions from our head that has imbibed on us for several years. So the first wrong explanation people say is, this is the earth. Earth in this case is the center of the circular path, in which the moon is the object of mass m we discussed right now. So in this case, the moon is that mass m which is revolving in a circular path. Actually, the path of planets, moons, earth they are all elliptical according to Kepler's laws of planetary motion, but the eccentricity in this case is tending to 0. That means it is almost a circle. So we can use the dynamics of circular motion here to understand this. So now let us start. Wrong misconception. Okay, people say the centripetal force acting on it, which is equals to mv square by r, is moving with a speed v. This is velocity v, its magnitude is this v, which means the speed of the particle. So centripetal force is being balanced by the centrifugal force. One thing, this centrifugal force is not a real force. Centrifugal force is a pseudo force which we can apply only while working from a non-inertial frame of reference. Non-inertial frame of references, when we go there, we can apply this pseudo force. Centrifugal force is a pseudo force, not a real force. So while studying this from an inertial frame, how we can apply this centrifugal force? Let us assume that somehow it is there, then centripetal force is balancing centrifugal force, so net force is 0. If net force is 0, then how it can move in circular path? In circular path, its velocity is changing because of change of direction. If net force is 0, that is never possible. So this is one very bad misconception that is there regarding why the moon doesn't fall. Let us proceed into the second. In the second misconception, the sun comes into the role play. Here the sun is there, the earth, the moon is revolving in a circular path. So let us consider two positions. This is one position, this is another position. In this position, sun is applying a force, force by sun. Earth is applying a force, force by earth. In this position, earth is applying a force in this direction and sun is applying a force in this direction. People say that the force of sun is balancing the force of earth on moon, so moon is moving in a circular path. There are two arguments to prove it wrong. First is, if net force is 0, it cannot move in circular motion, as I said earlier. And if we consider this position, the net force is acting in this direction. That means it should rush into this direction, but it is not happening like that. So these are few wrong things that are regarding this. Now let's proceed into the exact correct explanation of why the moon doesn't fall into the earth. The answer to the question is quite amazing. It is that at every instant of moon in its circular motion, the earth is attracting the moon and the moon is falling onto the earth. It is a very amazing that the moon is actually falling onto the earth, but it is never able to reach the earth. So let us understand how it is happening. Here it is the earth. In circular path, the moon is moving. The force is applied by the earth, the gravitational force by earth on moon. The velocity is like this. Let us draw dotted lines to indicate the position. So it is a position. Due to this force by earth on moon, moon is saying, okay, earth is pulling me, so let me go closer to earth. The moon is going closer to earth. Now see this displacement, this change in position towards the earth, how it has happened? Due to this gravitational force. This x change in position due to this gravitational force. That means yes, the moon is falling onto the earth. It is not that the moon doesn't fall. But the problem is the earth is also applying a force at every point. Its direction is changing. In circular motion, the direction of centripetal force changes. That is the main problem why the moon doesn't collide with earth. It falls onto the earth, but it doesn't collide. Here again, earth is applying a force, but it will change its direction. Like this, it will attract. Its direction is velocity is like this. So it will again repeat the same thing. If we draw dotted lines like this, it will again go here. Moon position is changing. So if the earth's force on moon is constant, it will definitely make the moon collide with it. But since its force is always perpendicular to its velocity, direction of force by direction of force by Earth on Moon is always perpendicular to the velocity. This is the reason why the Moon doesn't collide with Earth, because it is continuously doing free fall. It is continuously doing free fall, but it is never going to reach the Earth because of Earth only. The Earth's force on Moon is not constant. It is perpendicular to the force. I hope you got it. Thank you.